Life is all about maintaining balance. Balance between work and study, between study and friends, between friends and family, between learning and earning, and so on. Similarly, machines also needs to be balanced. So in this particular unit, we will study about how to balance a machine, because whether it be life or whether it be machine, if it is not balanced properly, it will lead you to Hello everyone. Now we have studied about static and dynamic force analysis in different mechanisms, and that is obviously very helpful in designing. Now one more thing to be considered while designing, and that is balancing, which is very important, because a component, if not properly balanced, will lead to the vibration of the whole system, and that will finally lead to the failure of the component. The failure of component increases manifold if the component is vibrating. So it is very essential to balance that component. Now what actually is balancing? Balancing is a technique of removing unwanted inertia forces and unwanted moment from the component. Now as and when we will move forward in this unit, you will understand this definition, don't worry about that. So before actually getting into balancing, let us first start with what actually is unbalancing. So now let us first consider this case. Suppose we have a rotor which is rotating on a shaft supported in two bearings. If the center of mass of this rotor coincides with the center of rotation, the axis of rotation, if the center of mass of the rotor coincides with the axis of rotation, then we can call that this component is a statically balanced component. Now suppose if we are having an unwanted mass here, a disturbing mass. So what will happen? This extra mass, because of this extra mass, the center of mass of the rotor and the axis of rotation will not coincide, because we are having an extra mass here. Suppose that mass is at a distance r. So this mass will produce a centrifugal force m omega square r, which is directed outward, obviously. And because of this centrifugal force, an acceleration is produced in outward direction, and therefore a inertia force is produced in the inward direction, as you can see here. And because of this inertia force, it will affect this bearing. Okay, so it is very important to balance this rotor, which is unbalanced because of this unwanted disturbing element. So how we can balance it? We can put another mass which is equal, the force, the equal and opposite force should be put in other side of this rotor in order to balance that rotor, to be very simple. So I will tell you how. So suppose we have this unbalanced mass m1, which is at a distance of r1 from the axis of rotation, and because of this force is produced, suppose Fc1, whose magnitude as we know will be m1 omega square r1. So in order to balance this component, we have to put equal and opposite force. So in order to put that equal and opposite force, we will put a mass. Suppose m2 mass is put at a distance r2, and the force produced by this m2 is nothing but Fc2. So for balance condition, obviously this Fc1 should be equal to Fc2, or m1 r1 omega square should be equal to m2 r2 omega square. The omega square will get cancelled out, and you will get what? M1 r1 will be equal to m2 r2. Okay, so this is the condition for a static balancing. And as I told you, static balancing is what? When we have to, our main purpose is to coincide the center of mass with the axis of rotation. Then we can say that the component is statically balanced. Okay, now here you can see one thing, m1 r1 is equal to m2 r2. So the product of m2 r2 should be constant. So in order to reduce mass m2, in order that the mass m2 should be minimum, the r2 should be maximum. R2 is taken as maximum. So generally the balancing mass is put in the surface of the rotor where radius is maximum. First thing. Second thing, you can see the centrifugal force is directly proportional to mass and radius of rotation. Because omega square is constant for both the cases, it will be cancelled out. So it is directly proportional to mass and radius. Okay, so you can take two important notes here. First, the radius of rotation of balancing mass m2 is generally made large in order to reduce the balancing mass m2. Second, the centrifugal forces are proportional to the product of the mass and radius of rotation of respective masses because omega square is same for each mass. So we have seen about single unbalanced mass in a single plane. Now is the case when we have multiple unbalanced masses in a single plane, like in this rotor. We have multiple unbalanced masses in the same rotor in the same plane. Now how to balance this? Okay, so for this let us consider this. Suppose we have a mass m1 which is at a radius r1, rotating at a radius r1 which is at an angle theta 1 from x-axis. Similarly, mass m2 at a radius r2 at an angle theta 2 from x-axis, positive x-axis. Mass m3 at a radius r3 at an angle theta 3 from positive x-axis, and mass m4 at a radius r4 and at an angle theta 4 from positive x-axis. Okay, now as I told you that these masses, these unbalanced masses will produce centrifugal force in outward direction. So this mass m1 will produce a centrifugal force Fc1, and which is equal to m1 omega square r1. Okay, but because omega square is common, we will take it just as m1 r1. Similarly, mass m2 will produce a centrifugal force m2 r2, mass m3 will produce m3 r3, mass m4 will produce m4 r4. Okay. Now first thing will be to determine the resultant of these unbalanced force, and once we have determined the resultant of unbalanced force, we can put a balancing force, a balancing mass in just the opposite direction of that unbalanced mass, resultant of unbalanced mass. Okay, so how to find the resultant? So as we know, if we have different vector, and if we want to find out the resultant of all the vectors, we can put those vector in the form of a polygon, and the remaining side will give us the resultant. This is polygon law of vector. Okay, so we will put all these vectors in the form of as different sides of the polygon. So we will put this vector Fc1 as one side of polygon. Now the head of this Fc1 will become the tail of Fc2, and the Fc2 vector is placed at the head of the Fc1. Similarly, Fc3 vector is placed at head of Fc2, and Fc4 vector is placed at head of Fc3, as you can see in the figure. Now the remaining side of the polygon will give us the resultant of the unbalanced forces. So we have this resultant as of the unbalanced forces. We will put this resultant here. So in order to balance this unbalanced force Fc, we will put a mass mb at a radius rb at diagonally opposite to this particular vector. Okay, and for balancing, this Fc must be equal to mb into rb. Okay, so from here we can calculate the value of this mb into rb, which is resultant which is which is balancing mass and the radius at which balancing mass should rotate. Getting this or not? Okay, so this was the method of this was a graphical method to determine the unbalanced mass resultant and the balancing mass. Now we will look at the analytical method. Obviously graphical method is not useful for you for GATE exam, so we will look at the same thing analytically. Okay, so we have different forces as I told you, Fc1, Fc2, Fc3 and Fc4. All these force components, all these forces will have two components, x component and the y component. Okay, so we will take the summation of this x and y component. So we have summation of fx is equal to m1 r1 cos theta 1. We are taking omega square out of this, plus m2 r2 cos theta 2 plus m3 r3 cos theta 3 and so on. Similarly, summation of fy will be equal to m1 r1 sin theta 1 plus m2 r2 sin theta 2 and so on. Okay, now if you want to calculate the resultant of this unbalanced masses, so resultant Fc will be equal to under root of fx square plus fy square, as we all know, summation of fx square plus summation of fy square. So from here we can calculate the resultant. So this Fc, the magnitude of this Fc is nothing but equal to mb into rb. So we can calculate the magnitude from here. How can we calculate direction? So the resultant force of the resultant of unbalanced masses will have the direction tan theta, which is equal to summation of fy by summation of fx. The tan theta will be equal to summation of fy by summation of fx. Okay, now the theta dash, the direction of unbalanced mass, the direction of balancing mass, as I told you, is at an angle 180 degree from the resultant of unbalanced mass. So theta dash will be equal to theta plus 180 degree. Getting this now? So this was static balancing. Next is the dynamic balancing. Now what is dynamic balancing? So in static balancing we have seen what we were having an unbalanced mass, and in the same plane we were putting another mass so as to neutralize the force which was produced due to unbalanced mass. Okay. Now if we are having suppose different unbalanced masses in different planes, so apart from producing unbalanced inertia forces, it will also produce unbalanced moment at the supports. So we will have to balance first the unbalanced inertia forces, and second thing is unbalanced moment. So this is called as the dynamic balancing. In static balancing we were balancing only unbalanced inertia forces. In dynamic balancing we have to balance unbalanced inertia forces as well as the unbalanced moment. Okay. So suppose we are considering this case, the same case, suppose we are having one unbalanced mass. Okay. So now we are putting this masses m1 and m2 at two different planes q and p respectively, and the distances are l1 and l2 respectively from the main mass, the unbalanced mass m. Okay, and because of this unbalanced mass, obviously a force Fc will be produced. Now for statically balancing this, the forces because of this Fc1 and Fc2, because of the mass m1 and m2 should be equal to that of the Fc. That means for statically balancing, Fc should be equal to Fc1 plus Fc2. Or you can say mr omega square should be equal to m1 r1 omega square plus m2 r2 omega square. Omega is same because that is rotating in the same shaft, omega will be same. Or you can say mr will be equal to m1 r1 plus m2 r2. So this is the condition for statically balanced. So this component is statically balanced, but the case is not over, because we have, in order to balance this Fc, we have put two different masses m1 and m2 which are producing Fc1 and Fc2 in two different planes. So we have to balance the moment also. The moment should also be equal to 0, otherwise the unbalanced moment will also produce the vibration. Getting this not? So the moment should at any moment about any plane should be equal to 0. Suppose we are taking moment about plane P, this moment should be equal to 0. So what will be the case now? This Fc1 into L should be equal to Fc into L2. The Fc1 into L, the moment of this force about this plane, Fc1 into L should be equal to Fc into L2. Or you can say m1 r1 into L should be equal to mr into L2. Okay, so from here you can get the value of this m1 r1. This m1 r1 will be equal to mr L2 upon L. Getting this not? Similarly, you can determine the value of m2 r2 as well. So how you can determine that? Just take moment about q, okay, and you will get what m2 r2 L is equal to mr L1, and from here this m2 r2 will be equal to mr L1 by L. Getting this now? Okay. So now we will solve one question related to this topic. We have four masses 200 kg, 300 kg, 240 kg and 260 kg has radii of rotation as 0.2 meter, 0.15 meter, 0.25 meter and 0.3 meter respectively, and angle between successive masses are 45 degree, 75 degree and 135 degree. Find the position and magnitude of balanced mass required if the radius of rotation is 0.2 meter. Okay, so what is given in the question? We have four different masses and at different angles. Suppose we are taking the reference plane at suppose 0 degree, the mass is 200 kg. Okay, and the radius of rotation r1 is given as 0.2 meter. Okay. Next, at an angle of 45 degree from this, we are having another mass, the magnitude of which is 300 kg and the radius is 0.15 meter. Okay. This angle is 45 degree. Okay. Next is at 75 degree from this plane. Okay. So from this plane we are having another mass at an angle of 75 degree. Okay, the magnitude of this mass is 240 kg and radius of rotation of this mass r3 is given as 0.25 meter. So now at an angle, last is at an angle 135 degree, we have another mass, the magnitude of which is 260 kg and the radius is given as 0.3 meter. Getting this or not? Okay, so from here you can conclude one thing, that this mass m3, this is suppose mass m1, m2, m3, and this is m4. Okay, so the mass m2 is having an angle 45 degree from here, mass m3 is having an angle 75 plus 45 degree, which is 120 degree. Okay, and this last mass is having an angle of 255 degree from the reference plane. Getting this now? Okay, now, okay, so in order to determine the resultant unbalanced force, first of all let us determine summation of Fx. So this summation of Fx will be equal to Fc1 into cos theta c1 plus Fc2 cos theta c2, Fc3 cos theta c3 plus Fc4 cos theta c4, and Fc is what? M omega square r, M omega square into r. Okay, omega square is taken as common, so this will be equal to m1 r1 cos theta 1 plus m2 r2 cos theta 2 plus m3 r3 cos theta 3 plus m4 r4 cos theta 4. Getting this? Okay, or we can write it as 200 into 0.2 cos of 0 degree plus second is 300 into 0.15 cos of 45 degree. Okay, this angle is 45 plus 240 into 0.25 into cos of 120 degree plus last is 260 into 0.3 cos of 255 degree. Okay, so from here the summation of Fx will be equal to 21.63 kg meter. On solving we will get this value. Getting this? Okay, similarly summation of Fy will be equal to the sine component. Okay, so this will be equal to 200 into 0.2 sine of 0 degree plus 300 into 0.15 sine of 45 degree plus 240 into 0.25 sine of 120 degree plus 260 into 0.3 sine of 255 degree. Okay, and from here we will get what? Summation of Fy will be equal to 8.5 kg meter. Getting this now? Okay, so resultant will be equal to what? As we know, under root of summation of Fx square plus summation of Fy square. Okay, so from here this resultant mass R is equal to under root of 21.63 square plus 8.5 square. So from here we will get this as 23.24 kg meter. Getting this? Okay, so this is the resultant of unbalanced forces. Now we have to put now what will be the angle for this? So we can determine the angle. So this tan theta c, tan theta will be equal to summation of Fy upon summation of Fx. So this will be equal to summation of Fy is 8.5 divided by 21.63. So from here this theta will be equal to 21.45 degree. Okay, so this is the magnitude of unbalanced mass and this is the angle of unbalanced mass, 21.45 degree. Okay, so we are getting this unbalanced mass somewhat here. The resultant of this unbalanced mass, suppose mc into rc, sorry, the resultant of this unbalanced mass r is here. Okay, now we have to put a balanced mass just at an angle 180 degree from here. यहाँ से सीधा सीधा 180 degree पे हम balance mass put करेंगे. Suppose the magnitude is mc into rc. Okay, so this magnitude will be same. That means this mc into rc will be equal to r, and which is equal to how much? 23.24 degree. Okay, and finally the angle theta dash will be equal to 21.45 degree plus 180. So this will be equal to 201.45 degree. Getting this or not? Okay, so what we have done is initially हमने जितने भी unbalanced masses थे उनका resultant निकाला, उसका resultant magnitude निकाला, उसका resultant angle निकाला. Okay, तो we will have to put the same magnitude mass here. mc into rc की value same रहनी चाहिए जो कि r की वैल्यू रिजल्टेंट की वैल्यू हमको मिली है फर्स्ट थिंग, और एंगल जो है दैट एंगल विल बी एट 180 डिग्री फ्रॉम दैट। ओके, सो MC into RC is equal to 23.4 kg meter and the angle is equal to 201.45 degree. Getting this now? Okay. Okay, next question. A mass of 9 kg is attached to a rotating shaft at a radius of 0.5 meter. The balancing masses B1 and B2 are attached at a radius 0.5 meter as shown. If the shaft rotates at 100 rpm, the magnitude of balancing mass B2 is. Okay, so this is figure given. We have to determine the magnitude of this mass B2. Okay, so in order to determine this, as I told you, we have to take moment about this B1. So what will be the moment? So this will be equal to MB2 RB2 into total distance, which is L. This is equal to MR into L1. Getting this? Or you can say MB2 into 0.5 into total distance L is 1.5 meter is equal to M is 9 into 0.5 into L1 is 0.5. Okay, so this 0.5 gets cancelled out, and from here we can get this value MB2 is equal to 9 into 0.5 divided by 1.5. This is 3 times, so this will be equal to 3 kg. That's it, answer. Clear or no? Okay, simple question. So we will solve few questions which were asked in previous GATE exam, from this topic of balancing. First question asked in GATE 2005. A rotating disc of 1 meter diameter has two eccentric masses of 0.5 kg each at radii of 50 mm and 60 mm at angular position of 0 degree and 150 degree respectively. A balancing mass of 0.1 kg to be used to balance the rotor. What is the radial position of the balancing mass? Getting this now? Okay, so what it is saying in the question, the rotating mass of 1 meter diameter. So we have a rotating mass of 1 meter diameter. This is having two eccentric masses of 0.5 kg at an angle of 0 degree and 150 degree respectively. So this is 0.5 kg and at an angle of 150 degree, again a mass of 0.5 kg. Getting this? Okay, the radii at which these masses are located are 50 mm and 60 mm. So this is 50 mm, this is 60 mm. Okay. Now a balancing mass of 0.1 kg to be used to balance the rotor. What is the radial position of the balancing mass? The balancing mass, that means MB is given as how much? 0.1 kg. We have to calculate RB. Getting this? Okay. So as we know, as I told you, first we have to determine the resultant of this unbalanced mass, summation of Fx and summation of Fy. So this summation of Fx will be equal to M1 summation of Mr cos theta. So this will be 0.5 into 50 into cos 0 plus 0.5 into 60 into cos of 150. Okay, so this will be equal to how much? This will be minus 0.908 kg mm. Okay, this is taken in mm, this is kg, so this will be minus 0.908 kg mm. Similarly, we can determine summation of Fy. So this summation of Fy will be equal to summation of Mr sin theta. So this will be 0.5 into 50 sine of 0 plus 0.5 into 60 sine of 150. So this term will be 0. So this will be equal to how much? 15 kg mm. Okay, so we can calculate resultant. What is resultant? Under root of summation of Fx square plus summation of Fy square. Okay, so just put the value. So this resultant, and as I told you, this resultant is nothing but MB into RB. So this MB into RB is equal to under root of summation of Fx square minus 0.908 square plus 15 square. So this MB into RB will be equal to 15.027. Okay, and we have the value of this MB. So this RB will be equal to 15.027 divided by MB, which is 0.1. So this RB is equal to 150.2 mm. So answer should be C, which is given as 150 mm. Getting this or not? Okay, next question. Next question, which was recently asked in your GATE 2016. Two masses M are attached to opposite sides of a rigid rotating shaft in the vertical plane. Another pair of equal masses M1 is attached to the opposite sides of the shaft in the vertical plane as shown in figure. Consider M is equal to 1 kg, E is 50 mm, E1 is 20 mm, B is 0.3 meter, A is 2 meter, A1 is 2.5 meter. For the system to be dynamically balanced, M1 should be equal to. Okay, so this is the system given. We have two masses M, and equally two masses M1 and M1 are attached in two opposite sides. The distances are given. This is distances E1, E and E1. This distance A, B, E, and one more distance is given, which is A1. This distance is A1. Okay, and the value of all these distances are given in the question. Now we have to balance this dynamically. So for dynamically balancing this, suppose we are considering the plane here, we have to take the moment about this plane and equate it to 0, as I told you. Okay, so for dynamically balanced, for dynamic balancing, take the moment about this plane and equate it to 0. So we have this what, M1 into E1 into A1, M1 E1 into A1 minus ME into this distance. What is this distance? A1 minus B, A1 minus B, okay, plus ME A1 minus B minus A. This should be equal to 0. Getting it? This distance is how much? A1 minus B minus A. Getting this now? So this should be equal to 0. Or you can say, so we can write it as M1 E1 A1 is equal to, take M into E as common, we will get what? A1 minus B minus A1 plus B plus A. Okay, so this A1 gets cancelled out, B and B gets cancelled out, we just have A. So M1 E1 A1 is equal to MEA, or you can write it as M1 is given as how much? All the values are given in the question. We have to calculate M1. So this will be M1. E1 is given as 20 mm. A is given as A1 is given as 2.5 meter is equal to M is given as 1 kg. E is given as 50 mm into A is given as 2 meter. Okay, so from here we can calculate the value of this M1, which is equal to 2 kg. Answer. Simple question. Getting this or not? Okay.